look at example of application of this to determine P critical using slope deflection equation method. So there are different methods, so you must be familiar. Method using neutral equilibrium, method using behavior of imperfect column. Now you have also method based on criteria where the stiffness becomes 0 for beam column. And also now we have a slope deflection equation. So methods that we will be looking at, and specifically we want to look at how to apply them. Okay. Now slope deflection equations are given in the form of, there are two main set of equations that, let me refresh. So slope deflection equation method is a method where we make use of this two set of equations relating the n moment to the n rotations. Okay, MA, MB as shown in the figure. These are the n moment, and there are corresponding n rotations. So there are two n's. Okay, and it is given by that equations EI over L, then multiplied with, so don't forget this EI over L, which is the rotational stiffness or bending stiffness of the member. Then there are alpha n, the coefficients, multiplied with theta A plus alpha F multiplied with theta B. And then the other set is for the other n moment, again EI over L multiplied with alpha F theta A plus alpha n theta B. And MA and B and theta A, theta B is defined following this coordinate system X and Y, and it is clockwise as positive. Clockwise as positive. And later I will show you, I think, where this equation come from. I think it starts from governing differential equation like this, where we cut through this deformed shape, and then write down the differential equation, solve the differential equation, and then finally we come to this set of equations. Okay, so that I will point out to you where do they come from later. So slope deflection equations, there are two conditions that we show here. The first one is there is no relative lateral translations. Okay? And the second set is there is, so the detail of this alpha n and alpha f, which is coefficients representing the bending stiffness, because you need to multiply alpha n with EI over L. So EI over L multiplied with alpha n gives you the stiffness, the bending stiffness. So alpha n is a kind of coefficients representing bending stiffness. Then the detailed alpha n, alpha f, the equations which I showed to you, you don't have to memorize this because this is very difficult to memorize. So you will be given this set of equations if you are asked to solve a problem like this. So alpha n, alpha f, and then it is given by this, and then what is pi n, what is given by this. So here, the important thing is when we want to solve this is a function of KL. This is a function of K multiplied with L, so KL. So what is K? I think by now you are familiar what is K. K is square root of P over EI. So it is a function of KL. Okay? And KL also can be related to the actual load acting and over the P critical. So KL actually has the information about P critical in the KL. So when we solve later, when we solve for this, we solve for KL first, and then from KL we get what is a P critical. So yeah, K is this square root P over EI, which is, you should be very familiar now. So this is, and then another condition is when you have relative n translations, and this is the equations, this is a shape that we use to derive these equations, and then so finally we come up with, when you have n rotation, you have these terms appear here, where delta is non-zero. When delta is non-zero, you have these terms appear. So when there is no relative n translations, there is no relative lateral translation of the n. So what is important is how much this translate relative to this. Okay, that is represented by delta in this positive y directions. So if delta 0, then you have this term 0. Okay? So in general, if you have rotations plus relative n translation, so this is the equation that we have to use for. This is a slope deflection equation that we have to use. Okay? And these slope deflection equations will be used to determine the critical load. Now, our aim to introduce this is to use these equations to determine critical load. Now, let's talk a little bit here again. This is what I mentioned also by referring to the equation alpha n and alpha f is when you multiply this one, when you multiply with EI over L, so it's a kind of bending stiffness. Okay, it's a measure of bending stiffness. Bending stiffness means how much moment is required to produce unit rotations. Okay? This is bending stiffness. So the higher EI over L, the more difficult to rotate. So this is a bending stiffness. And remember, it is a function of KL. Function of KL. And KL can be rewrite as pi multiplied P over P Euler or P over P critical. Okay? And that's why this is a function of this P over P Euler. So when we solve using this, we will first determine KL first. Then from there, we can determine what is P critical. Okay. So so this also I explained to you how the alpha n varies when the KL changes, which is when P changes, P over P critical changes, which means when the member is subjected to higher and higher ratio of axial load, then the alpha n will decrease. When there is no axial load, this is a conventional alpha n, a constant ratio 4. So when P increase relative to P critical, so you can see from the graph is getting lesser and lesser compared to 4 for alpha n. Okay. So this is another diagram showing how they change. Alpha n decreases, but alpha f increases from 2. So if the KL is a bit small, I think then there are not much changes. So, but when the KL increases exceeding some, then it starts to have more significant effect on the bending stiffness. Okay. So this alpha n is alpha f is also called stability functions. Okay, stability functions, because this is related to a member in compressions, and it can be used to determine P critical. Okay. So this is what I have covered last week. So I give you a brief recap first. Now, I will go to this, I think, shortly after I go through with you where does the equation actually come from. So this is applications of slope deflection equations to determine P critical of a column. And we will come back to this shortly. Now, where do we get all these equations? All the equations, I think alpha n and alpha f is, that is the derivations, okay? Now, I just go through with you the overall process of derivations, okay? And this one is coming from okay. So we go through the relevant chapters there. This is chapter 3. This is chapter 3. Okay. Chapter 2. It's a bit too small. I think I put on the glasses also cannot see clearly. Focus. Nothing wrong with this. In the afternoon, it becomes like this. Now, this gives a very detailed explanations about where do we get the equations. Okay. Now, let me go through with you the overall process first. Then before I come back here, then it is easier for you to follow because there are a lot of mathematics there. That understand the overall procedure first. What we want to get is the end moment and the end rotation relationship. Okay? That is the main thing that we want to get. So that is the A. Okay? And to do that, we first, okay, so there are two cases that we consider, which is without relative n translations, meaning that delta L 0. Okay. And there are second cases, which is with relative n translations, which mean delta over L is not 0. Okay. What we want is the equations MA EI over L alpha n theta A plus alpha F theta B and MB equal to EI over L alpha n theta B plus alpha F theta A. Okay. So here, the same thing, EI over L alpha n theta A plus alpha F theta, the other end there, theta B. Then there is a minus, okay, here, if alpha n plus alpha F delta over L and MB is the same thing, EI over L. So don't forget this EI over L. Okay? EI over L alpha n theta B plus alpha F theta, the other end opposite to B minus alpha n plus alpha f delta over f. Okay. So the aim of the derivation is to get these two set of equations. So when we start with this, so we want to get to this equation. So when we go through the derivation process, so we first we get the governing differential equations, okay, which we get first. Then we solve to determine y. Okay. So this is y. So we solve to determine the y. Okay. Now, after you get the y, because you want to get the rotations, then you differentiate y to get theta. So you get y, if you differentiate, which means you do dy dx, you will get theta. So you differentiate y, which is you obtain here by solving this governing differential equation, then you get the equation for theta. Okay? Then for this equation of theta, we get what is theta A and what is theta B. So theta A is at one end of the member, which is when x is equal to 0, and theta B at the other end of the member when x is equal to L. So when you substitute x is equal to 0, you get theta A from these equations. When you substitute x is equal to L, you get theta B from these equations. So you get two equations, theta A and theta B. Then you rearrange them to get MA and MB. Okay? So that is the process. Actually, that is, I'm going to go through with you the derivation process. Okay? So after you get this, then number 4, let me write down over here. So number 4, let's see. Okay. So number 4, after you get this, will be substitute x is equal to 0 and x is equal to L into the equations for theta to get theta A and theta B. Okay. So you get these two equations, and finally you rearrange, okay, the equations for theta A and theta B to get equation for MA and MB. Okay. And that equation will be this and this. So basically, this is a flow of the process. And then mathematically, there are things that we have to do. But the aim is to get to this equation. This, when we follow through this 1, 2, 3, 4, 5, finally we get this. So the same thing we do for this case. Okay? The aim is to get that two equations, but then the things that we have is different, that is without n rotations. Okay? Here will be, okay? For this part, you have, remember, it is relative n translation. Okay, so this is delta. This is again L. Okay, and there is a moment, you know, and you have another moment here. Okay, and our coordinate axis is like this. This is y. So delta is in the positive direction of y. And if this is A, this is a B here, then we assume clockwise as positive. So here, when you have positive translation here, you get this kind of moment. So this becomes negative. Okay. So relative n translation will cause moment as well. So when you have relative n translations, it will cause moment at both ends. And we put negative here is because our assumption here is clockwise is positive for this coordinate system that we are using here. So starting from here, again, we follow this process. We follow this process, okay, in order to get to these equations here, which in order to get to this part here. Okay. Because here when we derive this n rotation and this n rotation is 0. We assume them to be 0. Only there is relative n translation. Here rotation 0, here rotation 0, and we will get these terms here. Okay. So the procedure here will be the same. Go through this, get this, and then go through this process until finally we get the equation, which is the moment, n moment caused by relative n translations. Okay. So with this general flow, then it will be easy to follow through the derivation process written in the book. Okay. Only there are some mathematical aspects that you have to be familiar with. But if you understand what is the aim, then we can follow better the solution, the derivation process. Okay. So now, let me brief you, guide you through the derivation process. So here this is not clear, especially now in the afternoon is even not clear. You get so now in the morning is very clear. In the afternoon it becomes like this. In the midnight it's very clear. In the morning clear. In the afternoon become like that. At night cannot see anything. Okay. So you start with the governing differential equations. Okay. Then you write into this form. Okay. Equation 3.32. Okay, where you introduce the terms k square. Then you solve them, equation 3.34. Then you have a and b, which you solve using boundary conditions. So finally, you get the equations for y. But at this stage, of course, we need to know what is a particular solution depending on what is on the right-hand side of equation 3.32. So by now, if you're asked to solve like this, always we have these terms appear. A sin kx plus b cos kx always is there. Then plus another one if the right-hand side is not 0 in equation 3.32. So get what is a and b. This is all mathematical. Try to get y first. What is y? Okay. So once you get the y, which is here, then you differentiate dy dx, you get the rotations. Because we want to get the rotation. So we differentiate this. Then there are some mathematical process that's related to sine, cosine that you can simplify. So it becomes equation 3.37. So equation 3.37 is the general equation for rotations. Then you put x is equal to 0, you get theta a. Then there are some manipulations here, okay, which is explained here. Then you get to 3.39, okay, equation 3.39. So theta a will be given in terms of this. So this is where you start to see this thing appear here, theta a. So you get first theta a equal to something ma something plus mb something, because they start with theta a first. Then we do the same thing, we get theta b. You get theta b, so theta b is by substituting x is equal to L into this equation 3.37, then you get 3.43. So 3.42, this equation and that equations, you rewrite them to make MA and MB as the title of the formula, okay, and introduce all these terms alpha n, alpha f, and finally we get this. So this is a very clear explanation about the derivation process, and there are involving some mathematical manipulations, sine and cosine, to simplify and introduce the term alpha n and alpha f. Okay, so that is why we come to this. And if you proceed to the next one, which is this one, then the same thing, you get the governing differential equation first, okay, which is equation 3.49. Then you get the solution for that. Then again, this a sin kx and b cos kx appear. All the time it follows. Okay. Then a and b appear, need to use the boundary conditions. So we get a and b, substitute, then we get 3.51, get the rotations because we want to get theta. So differentiate this, get to this, okay? Now there is additional steps which needs to be considered here, okay? The conditions of, another conditions of dy dx is equal to 0. So we get an equations for delta over L. We get the equations for delta over L, which is given by 3.53. Then we write down delta over L in this form, okay? Or delta over L, introduce pi n and pi f, that we have introduced, used pi n over pi f. There are some mathematical manipulations here, okay? Then we introduce this pi n and pi f because pi n is this, pi f is this. Right. Then finally, delta over L will come to these equations, and then we rewrite this, make m as the formula of the equations, then we get to this. So k here is EI over L, then alpha N plus alpha F delta over L. So that is the term there, okay, which is for this case. Okay. So we add, if we have N rotations and relative N translation at the same time, so this one must be added to the alpha N theta A plus alpha F theta B, okay, and then complete the whole equations. Okay. So here, if you go through here, it gives you a very clear, because its explanation is very clear here. So what I got you through, I think, what is the aim of this and why we go through all this, what is the purpose finally. Okay. So that is what is being given here. Okay. Now, after this, the main thing is we want to look at how to apply this set of slope deflection equation to solve for P critical. Okay. So the equation that you need to know to be used is MA, okay, as written on the whiteboard there, MA plus MA equal to, in general, EI over L, on that side, on the right-hand side of the board there, alpha N. So remember there is an EI over L first, which is K in this, which is represented by capital K in this book here. Then multiply in the parenthesis alpha N theta A plus alpha F theta B minus parenthesis alpha N plus alpha F delta over L. That is for MA, and same thing for MB. Right? Now after this, after we take a short break, I will explain to you how to solve this and why is alpha N, what is alpha F, and what actually how we solve this. Because this equation alpha N is very complicated equations. No, is considered a types of when you have relative N translation, it's not imperfections. It's a kind of when, for example, if you consider a frame which is not braced, when the frame can go sideways, okay, then you have this kind of situations. Or when you have a beam and there is a settlement, there's a settlement on one side relative to the other side. So you have one end going down relative to the others. So this is the situations. It is not related to imperfections. Okay. So this will be one situation, will be a frame with sway. Then you have that delta over L. Okay. If the frame without sway, then you don't have that relative N translation effect. Okay. But if the frame sway, so when the frame sway, so you have translation of one N relative to the others. So this is where the delta L appears. Okay. Okay. So we'll take a short break of 5 minutes. Then after that, I go through with you the application part of it. Now I hope you all get the video. Yeah, I see. I don't know the video that I recorded. The recorded class are all uploaded